Here I am going to discuss the problem number 1 of the test number 3. First one, CDF is given. Part A is asking determine the constants A and B. Right. This is from the theorem 4.1 in my textbooks, page number 160. So first property, limit x approach to negative infinity fx equals 0. So this is x less than or equals 0. So x approach to negative infinity, we should consider this one, that is a. Therefore, from this you can say a equals 0. Property number 2, limit x approach to infinity fx equal 1. So x greater than equal 1. So b equal 1. Right? If you need, you can write the fx now. Fx equal a equals 0 when x less than equals 0, x to power 2 when x in between 0 and 1, then 1 when x greater than equal 1. Actually, you don't have to memorize these two properties. Why? You know, we always write down the first part of the CDF, the first part equals 0 and the last part equal 1. So if you write down just a equals 0 and b equals 1, yes, I gave you the full credit. Right. So then part B. What is the part B? Find the PDA of x. Be sure to give the formula in the standard form. Yes, you should give the formulas in the standard form always, right? So we need to find the fx. How do we find the fx? Fxx. Here also you can write down fx. You can write down fxx, right? That is, I write down here fx, right? So fxx. How do we find the fxx? You know fxx equal the derivative of the fxx with respect to x. So here we know we have x squared between 0 x1. Therefore, what is the derivative of x to power 2? That is 2x, right? That is 2x. Therefore, we can write fxx, that is 2x in the range 0 x 1, and otherwise it is always 0, because you know the if you need to consider one by one, this derivative is 0 and 1 is the constant. Derivative of a constant is 0, therefore always the 0, but we consider only 0 between 0 and 1. So that is the PDA, the answer for the part B, right? So then go to the part uh, part C. Calculate the expected value of x. Actually, you should know the definition of the expected value. Expected value of x, we always know negative infinity to positive infinity. X fx x dx. Here you see this part, this one pdf, not the cdf. So pdf is 2x. Most of you have used cdf, completely wrong. Okay, so we know our range is 0 to 1, right? 0 to 1 x. Then what is the pdf? Pdf 2x dx. So you can take 2 out. 0 to 1 x to power 2 dx. So you know how to do these calculations. The cal 1 or actual cal 1. So I write the answer, it is 2/3. So that is the expected value of x. Right. So next one, part D, calculate the standard deviation of x. Yes, standard deviation is sigma. First we find the variance of x and get the square root of that. Okay, variance of x, we use sigma square. Right. How do we find the variance of x? To find the variance of x, you should know this formula. Variance of x equal e x squared minus e x to power 2. So we already know ex, right? It is 2/3. Right. We have to find e x to power 2. So by the definition again, e x to power 2 equal negative infinity to positive infinity x to power 2 fx x dx. From this we can apply to the our problem. Here again we know 0 to 1, then x power 2 and pdf is 2x dx. So again you can take 2 out, 0 to 1 x to power 3 dx. So you know how to integrate this. X to power 3 is the x to power 4 over 4. Then you can plug the 0 and 1. Then answer is 1/2. Now we know x, uh, expected value of x and expected value of x to power 2. Okay, so from this you see that you can plug the numbers. So variance of x equal 1/2, right? Then minus ex to power 2 is 2 over third. This is 1 over 18. But they're asking sigma, that is the standard deviation. So you can write 1 over 18 is square root. You can leave the answer in this format.